Okay, so guys, in this video, I just want to talk about the formulas for SOHCAHTOA, for basically for your trig functions, and the different worlds that it can exist in, and how you would approach problems based on what someone is giving you. So, in other words, a lot of you from geometry remember the sine, cosine, and tangent as SOHCAHTOA, and they were these ratios with your triangle in terms of the adjacent, hypotenuse, and opposite, where you could solve a problem for an angle or for a side. But the idea is like, what if you're not on a triangle? What if you're on a circle instead? Or what if you're being asked questions that pertain to the unit circle? So I'm going to do a few problems where I show you, based on what's given, how I decide which formula to use. So without further ado, there may be a little bit of scrolling up and down here. We'll see. Maybe I can shrink this down a little bit. Okay, this might be good. All right, so as I start, let's see, maybe somebody's given me something like, maybe someone's actually shown me a triangle. And in this triangle, I see a theta, maybe I see a 5 and a 9, okay? And maybe the question's not asking me to find something unknown, but somebody's asking me to find, like, hey, what is the sine of theta, or the cosine, or the tangent? And they want me to just find what they are. So if I see a triangle, I'm going to use something from this column right here, because this is the one that pertains to triangles. So the first step would be actually sketching on my picture, writing out what the opposite, adjacent, and hypotenuse are. If theta is here, that does make 5 the opposite, and it makes this side over here the adjacent. And the 9 is the hypotenuse because it's across from the 90. So those would be the sides that I know. And I want to start filling in these ratios, but the problem is, guys, I don't know my adjacent side. So the first thing that I would probably do is Pythagorean Theorem to figure that out. You know, you could put maybe you could call that A because you don't know what it is. And I'm going to run that formula, which was A squared plus b squared equals c squared. And in the spot of A, I don't know what it is, but the b is just the other leg, and the c is always the hypotenuse. So I'm going to do Pythagorean Theorem to figure this out. So the way this works is you will subtract the 5 squared to the other side. So this is an 81 minus a 25. I'm just doing a little mental math here. So a squared is what? 81 minus 25. Geez, what is that? I can't think about that right now. 56. And so a would be the square root of 56. Now, if this breaks down, we are going to reduce it as much as possible. And then if it doesn't, we're going to leave it right there. So to break it down, I'm just going to try to see if numbers go into it, like 4. 4 actually does go into it. I want to see maybe 9 will go into that. 16 maybe goes into that. The biggest number that I can find that goes into it is going to be what I want to go for. So I'm getting 4 goes in there 14 times. So if 4 goes in there 14 times, I'm going to split that up. And then that's going to become a 2 root 14. So in the place of this, I'm going to put a 2 root 14. Okay, so now I know all of my sides, and so when I have to do the sine, I just look up here and I snag this formula, which says opposite over hypotenuse. So in the spot of the opposite is a 5, and in the spot of the hypotenuse is a 9. So that one is done. Cosine is the adjacent over the hypotenuse, so I would do 2 root 14 over the hypotenuse, which is 9. Done. And then I'll do my tangent, which is the opposite over the adjacent. So the opposite was 5, and the adjacent is 2 root 14. Okay, I am actually not done with this one because you are not supposed to have a radical on the bottom. So I'm going to multiply both the top and the bottom by the square root of 14. This is called rationalizing, and it's going to clear that radical on the bottom. So now top times top is 5 root 14. The bottom times the bottom is going to end up being 2 times 14, because it's going to, root 14 times root 14 is going to cancel the radical, so it's just going to be a 14. So this is going to be 5 root 14 over 28. Whew, okay, so that's an example of how you can find some trig functions based off of a triangle. Of course, I could do these other 3 as well. I'm just not going to do it for the sake of time in this video, but you could do anything that somebody asks you. All right, so that's what I do when I'm given a triangle. So let's change gears to if I am given something different. Okay, so let's say the problem is something like find the sine, cosine, and tangent for the, find the sine, cosine, and tangent for the terminal side through the point 2, 4. And it would probably actually say find the sine, cosine, and tangent for the angle with the terminal side. That's probably better English. For the angle with the terminal side through the point 2, 4. So the first thing you want to do when you read a problem like this is probably visualize or sketch out what's actually happening before you can decide which formulas to use. So I'm going to sketch an x and y axis. I'm going to go to the point 2, 4. And I'm going to imagine a circle is around that point. Now, I'm not going to draw the whole circle because let's get real, it's not going to look good if I'm trying to do that, but you get the idea. You're imagining a circle all the way around and it's going through that point. And the reason I like to visualize that is because it helps me make a choice as to what formulas to use. Like I know that the x is 2, and I know that the y is 4 because it literally told me those two. But what I would like to know also is probably the radius of this circle. And the reason I want the radius of this circle is because since I'm not on the unit circle, I'm on a circle of radius r. I don't know what that r is. I need to find it so that I can use these formulas that I just circled over here. So my first step would be almost imagining a triangle there and doing Pythagorean Theorem, because that's just over 2 and that's just up 4. So if that's over 2 and up 4, then those are going to be the legs of my triangle. So I'm going to do a squared plus b squared equals c squared, just like I did on the last problem. We're just doing Pythagorean Theorem. And the legs are your a and b. So this will be a 4 plus 16, which is a 20. So 20 is c squared. So c is square root of 20. So let's break that down just like the last one. That's going to be 4 times 5. So that's going to be 2 root 5. Okay, whew. So I do all this work to find my r. But now that I have my r, and I have my x, and I have my y, this is going to be a piece of cake. It's actually easier, I think, than SOHCAHTOA, because now if somebody wants sine, cosine, and tangent, all I have to do is plug them into these formulas here. So if I look above, it says that sine is y over r, cosine is x over r, and tangent is y over x. So now I'm just going to plug in the values I have circled over here. So my y is a 4, and my r is a 2 root 5. So sadly, this is like the last one where there's a radical on the bottom, so I need to multiply the top and bottom by root 5, so root 5 over 5. So this is actually going to turn into, let me erase some of my scratch work here. This is actually going to turn into 4 root 5 over 2 times 5, which is 4 root 5 over 10, and then you can reduce that, so that's going to be 2 root 5 over 5. I just reduced these by 2, so I divided out a 2 from top and bottom. So that's my answer for cosine, or sine. Cosine is x over r, so this is going to be 2 over 2 root 5. So it's going to be very similar to the last one. So multiply top and bottom by root 5. It'll become a 2 root 5 over 10. And then I can reduce. So that'll be root 5 over 5. Okay. And then the last one is y over x. So the y is 4, the x is 2, and that reduces to 2. So there I have my 3 examples. So the only thing left is to look at what if I'm on the unit circle, and like how will I know that I need to use those values instead. And the way that that's going to work is basically if you recognize the value that's given, like if you recognize that somebody has given you a radian or a degree from the unit circle. And sometimes it's pretty easy and sometimes it's tricky. So let's say that somebody gave me like the tangent of 210 degrees. Okay, well that 210 I know is on the unit circle, so I don't need to draw triangles or anything. I can just think about where 210 is, which is right here. I can go grab the x and the y that's there, and the x and y at that point are negative root 3 over 2, comma negative 1/2. And then I just put them into this formula. So the y goes on top, the x goes on bottom, and then I do a little fraction math. Negative 1/2 is divided by root 3 over 2, which means if I do that keep, change, flip, I'm going to keep the 1/2 the same, change this to multiply, and then flip the bottom fraction. And now I'm getting 2 over 2 root 3. Those 2's will reduce, so I have 1 over root 3. And I wish I could leave it alone, but I can't because there's a radical on the bottom. So times root 3 over root 3. So this problem is going to become root 3 over 3 as a final answer. And it will be positive because I had a negative over a negative. Let's do another example that might be a little bit trickier. So what if somebody gave me like the cosine of 5 pi over 2? So if you're given this, at first you might look at your unit circle and you might think like, I can't do it because this isn't on the unit circle. But I want to remind you guys of coterminal angles because maybe this is just too big. You know what I mean? Like maybe it's more than one revolution around the circle, like somebody's taken some trips around. So what I'm going to do is I'm going to subtract this by 2 pi. Because that is how I can bring this back to one trip around the circle. I'm going to subtract revolutions, just like I was doing coterminal angles, to try to see what angle this matches with. So I need a common denominator, which means I need to make this a 2 on the bottom. And if I multiply the bottom by 2, I need to multiply the top by 2. So this is going to become a pi over 2. And so once I did that subtraction of 2 pi, that's kind of awesome because now this is the same as if it had said cosine of pi over 2. And since that's on the unit circle, the cosine is just the x value at pi over 2. And I can visualize pi over 2 is the top of the circle. I know the point that's there, that's the point 0, 1. So the x value is 0, and I'll have my answer. So that's how all of these could be approached if you notice that it is just a value given to you behind, you know, one of the trig functions, and you recognize that it might belong on the circle. Just try subtracting 2 pi, or try, if it was in degrees, try subtracting 360, and get yourself on the unit circle, and then use the values given to you that way.